Hi guys, so welcome to yet another project demo. So this is a backend project I did to try and understand the intricacies that are in backend development, especially when we are developing distributed systems. So as you know, in distributed system, you can either decide to distribute your data or distribute compute. So this is a document search system that I built where we went with distributing our compute. So what the system does is using the TIDF algorithm, we search for words in a corpus of texts. So how it works is when we send a request with a search term, the search term is searched and the documents are ranked with which documents are likely to have this search term. So this is a demo I'm going to do, but the demo will focus on distributed systems, so how they elect leaders, how it fails, etc., how work is distributed, and so on and so forth. So let me just log in here. And this same command, we can run it here, and then we run it in this other. Yeah. So I have 4 shell terminals open, and each will act as a node of the distributed system that we built. I have built this in Golang. So a step-by-step build will come if we get good traction, like around 20 people want to see it. I'll sit down and we will build this live on the channel step by step, but for now we're going to do just a demo. So I've compiled it, and I ran the terminal with I ran the system with /node. So the binary is called node. If you do /node in Go, if you're a Go developer, you know it will run the terminal. So let's take a look at the logs. So our orchestrator is zookeeper. So it is at the core of our system. So when a system comes live, it posts its address to a znode on zookeeper. We poll that to know the state of the system, the leaders and the workers, etc. So right now I've just spawned one instance of the system, so definitely it will be the leader. So I created a script here for testing this. So like a search query, we send this search query, and then it sends it to the system, and then we get back the results. So let me just open my terminal here and run this so that we can see. So it's in /scripts test, we test search. So it builds the client, and then we'll send the query because it's a gRPC client. So it will send the query, and then we will see. So our search term that we sent was whale, ocean, captain. So this is the documents that we have. We have documents here. Inside the resources, we have these books. So the search term is being searched inside these books. So if we look at what we have here, let me see if I can expand this. Yeah, so using the TIDF algorithm, we've ranked, so it's likely, so the search term is likely to appear in this corpus of text rather than anywhere else. So not rather than anywhere else, so as compared to the 20 that we have. So going back to distributed systems, let me put this back to the IDE. So if we take a look at what is happening, is the first instance that we have is elected as it takes the leader role, and then the node starts, and then it receives the search request that we sent. So there are no workers. So what happens when we have no workers? The leader will act as a worker. So it will process all the 20 documents locally, looking for that search term in them. So you see it has processed 20 documents. Right, so that is let's kill it and clear the screen and then run this again. So I want us to note what happens when we add another one. So let's run node here, and then on port 8081 now. You see, it is spun up as a worker. But what happens to our leader? Our leader updates its cache addresses for the worker service registry, and now we have one worker. So what happens when we send the search query now? So when we send the search query now, let's go back and analyze. So our leader receives the search query, not our worker. So our leader receives that, and then it checks how many workers it has in the pool. So it is sending the tasks concurrently to only one worker, because that was the worker we had on the pool. And you can see that this worker now, it processes 20 documents. So we had 20 documents in our registry, as I shown you previously. So how distributed systems work is, we say that we are going to distribute compute. So I expect that when I spin another worker, we are going to spin this on port 8082. It is registered. But now what happens when we have two workers in the pool? Let's send our query and then analyze. So when we have two workers in the pool, as you can see, the leader receives here. The leader will receive the work. It will create tasks for two workers. So it is distributing the tasks to two workers. So you can see that 10 documents are sent to 8082, and then 10 are sent to 8081. So 10 documents are sent to 8082, 10 documents are sent to 8081. If we check these workers, we see worker 1 processes only 10, and then worker 2 processes only 10. If you check at the titles of this, the titles that were sent to worker 1 are not the same titles that were sent to worker 2. And we can spin a third one on port 8083. It will be added, and when we run our search query, it is going to go. We are going to now have, this one will have the 7, this other one 7, and then the last one will be given the rest of the work 6. So I've shown you how work is distributed. That is, now we are distributing compute. Each node computes, and then the leader will receive the results and do the final computation. So what happens if we kill a worker? If we kill a worker, our worker pool addresses are updated automatically, so that the next time we have work to do, this worker will not be in the pool of active workers. So let's bring it back. And then now what happens when we kill a leader? So if we kill a leader, a worker is elected as a leader. You see, right now, this worker is the leader. If we kill it, we are going to elect this one as the leader. And then if we kill this one, the last worker is going to be promoted to a leader. So this is a demonstration of a project you can present as a backend portfolio project because it involves a lot. So what I'm going to say is, if you would like to see this being built in real time, leave a comment below, and we can start a series where we build such type of projects from the ground up. Thank you, and share with a friend who can benefit from this.